welcome back. Let's quickly summarize what we have done until this point. We have introduced the Flux architecture and we have introduced single store architectures. We have set up the store of our application and written our reducer functions. And we have set up the skeleton of our application. We have a series of smart components that get injected the store and know how to retrieve data from it, mapping it into view models that are then injected in the view. We also have created presentational components like the message list or the thread section list components that are simply components for displaying data on the screen. They receive an input and they produce an output view. They can also emit events if needed. So with this in place, we have built the thread section summary of our application, so the left-hand side where you have a list of threads for the current user, and the right-hand side where you have the list of messages of the current thread. Now what we're going to do in this section is we are going to finish the chat application. So we are going to start by implementing the send new message functionality that allows you to send a message from participant A to participant B and save the message on the server. After that, we are going to implement the refresh messages functionality that will allow us to view new messages that were sent by another user on the same thread. Last, we are going to mark the threads that have unread messages that are not the current thread as having messages that are going to be read later. So this will be displayed on the messages counter, the unread messages counter. So you probably remember that this counter is actually the functionality that was so hard to implement in the Facebook UI. And at this point of the application, we are in a position to understand why, what was the root of the problem. The problem is that there is a mapping between a view and a view model in basically any user interface that we will build. A fundamental architectural decision is, where will that mapping take place? Will it happen on the server or will it happen on the client? The thing is, if we do it on the server, mapping the model into the view model, and we bring the view model across the wire, what will happen in complex user interfaces where we have on the same screen at the same time multiple views of the same model? What will happen is we trigger an action on the client, we will have to send a request to the server, and then the multiple views on the screen of the same model will have to refresh themselves somehow in order to be updated. This is because the mapping between the model and the view model is being applied on the server and not on the client. Now, how could we avoid this refresh operation that the multiple views of the same data would have to refresh themselves? Well, one way would be for one part of the application that triggered the change to notify other parts of the application via, for example, a custom global event that a change occurred. So let's say that, for example, other parts of the application can update their view models in response to that change. As we have seen in the lesson about custom global events, that approach does not scale in complexity, meaning that it's very easy to fall into situations where it's very hard to maintain the code. With a store-based architecture, we have moved that mapping from the server to the client, so we are bringing over the wire the main data and not view models. So now we keep that data in a central location in our front end. Whenever we do a modification, we modify that data in memory and report that to all interested views of that same data. This means that we can have very advanced user interfaces that show several view models of the same data at the same time on the same screen, without the need to constantly refresh everything, which would cause a bad user experience. And we are going to see how a store-based architecture really makes it simple to implement this kind of UIs. Also, after this section, we are going to add another section where we will dive deep into the ecosystem of NGRX and NGRX Store. For example, we are going to be covering immutability, NGRX store freeze, we are going to talk a little bit about Immutable.js, and we are going to cover the integration with the Angular router. The last section will be a description of how to implement a server similar to the one that we are using here. Okay, so First, let's finish the chat application. The send new message functionality is coming right up in the next lesson.